Okay, so let's get started. So this is section 11.4, and it's called vector equations. You don't have to change the name if you have the name from yesterday. So vector equations of lines and planes. Okay, 3D. It's probably called better equations of lines and planes 3D, which is probably what I called it yesterday. Okay, so I want to start with, we have a person. So we said Eric. So we're going to go Eric to the exit sign. So I called that S for sign. Okay, so SIGN, sign. Okay, so in my classroom, you can imagine that. So say Eric is sitting at the point 1, 2, 3, and the exit sign is at the point 10, 20, 40. Okay, so the exit sign is at the point 10, 20, 40. And I want the equation of this line. Now, technically, it's a line, so it goes in both directions. But just imagine, because for right now, we'll go backwards too. But basically, I'm trying to get from Eric to the exit sign. Now, in 2D, your process would be find the slope, right? So you'd find the slope. You do m equals y2 minus y1 over x2 minus x1. And then you'd probably, if you want to do well in calculus, get used to using point slope form. Okay, so you'd want to use point slope form. Okay, and if you have your microphone on, I know we turned them on, you might want to turn it off just because otherwise it's going to keep putting your picture in the front, because if you hear any background noise, then it throws your picture to the front. So it's okay, but it might be a better idea for you guys to turn off your, I think Patrick, yours might be the only microphone on, so it might be a good idea to turn it off, or it keeps throwing you to the front.
Okay.
Which I don't mind. I don't mind, but anyway. Okay. So we have this. So that's what our plan would be in 2D. So in 3D, we can't do a slope. So we have a significant problem. Now I can feel a slope. I just can't do a slope. So it's very interesting. Now, I've always wanted to call this the M vector. So this year is my first year. I'm going to call it what I want to call it. Okay, so we're going to call it the M vector. So M stands for slope. Okay, so we're just going to call it the slope vector. Okay, so we're going to call it the slope vector. So if you look at the picture and you say, hey, what's the slope vector? Well, in this case, wouldn't the slope vector be ES? You know, ES or SE, right, in this case? So what would the slope vector be? The slope vector would be, well, I got to get from Eric to the sign. So in the X direction, I could say, how do I get from 1 to 10, which is 9? Or I could say, how do you get from, I could subtract backwards. I could do 10 minus 1. And then this would be, I need to have 18. And this one would be, I need 37. So that would be the slope vector. So how do you get from E to the sign? You kind of take, so this is just, I'm going to put in my head, okay, because this isn't official, but it'll be helpful to write. Okay, the bubble means in my head. So basically, you're taking point E, and to get to S, aren't you kind of saying, well, I want to take E and add the slope vector, and that gets me S? But point E is a point, and point S is a point. So technically, you're not allowed to add points and vectors. But I mean, isn't that really what you do? You know, you take the E coordinates and you add the M components, and that gets you to the S. So it's like you're adding a vector, but officially, there's no math operation that allows you to add points and vectors. Okay, but we can add points and vectors. We just can't do it if I write it as a point. Okay, so there's something called a position vector. Okay, so let me show you what a position vector is. So we're going to call it, usually they call it A. So vector A is going to, and I'll write this over here, position vector. So what a position vector is, and this is the theory, is I'm looking at point E, but I can't add it to my M vector because it's a point. So I'm looking at the point vector and saying, well, I could just add the 1, 2, 3 to 9 to 18, 37, and I'm going to get 10, 20, 40. Like, I would love to just do that. So what I call it, it's called the position vector. Okay, but what I call it is I call it a point written as a vector. Okay, now, a point written as a vector is you just take the point and you write it as a vector instead. But the official way you would do that is you would call it OE. And then OE is the vector / point 1, 2, 3. Now, can I add vector A to vector M? Yeah, because they're both vectors. So I can legally add them. It's like a fake. Okay, turn off your microphone, or you could type in the chat if you want to answer my question, which is, what does O stand for?
Origin?
Origin, exactly. So to go from the origin to the point 1, 2, 3, isn't that the vector 1, 2, 3? Because you're going from the origin. And so it seems kind of silly, but we're doing it because we can't legally add a point to a vector. So it's just kind of how we force it to happen. Now I have a question. Is S the only point besides E that's on the line? Anyone? No, exactly. So there's many more points on the line, right? So how about, let me zoom out. How about this point right here? Okay, so we'll just call this point X. Okay, so that point X, how would you find those coordinates? How do you find the coordinates of X? I tried to make that equal, so the sign is in the middle of E and X. Yes, you add the vectors. So it's like you would add, say you started E. Couldn't you add vector E, let's just say, to get to X, right? Couldn't you say point E plus twice vector M? Wouldn't that be point X? I'm going to put it in a bubble. Right? Point E plus 2 M's is point X. Or point E plus half an M is point H. So if I want all the points on the line, I just have to change the number in front of M. Okay, so this is the theory. Okay, so this is the theory, but let me show you the how-to. But the how-to is not bad. It's pretty nice. So this is the how. Okay, so this is what you actually do. Did I write example? I did not. So let me write example. Okay, so this is example how. So this is example 1. Okay, so it gives you a point. So we'll call it A. That's 1, 2, 3. Okay, and then they give you another point B. Let's call it P and Q. It's better if you call it P and Q. Okay, so P and then Q. And then this is the point 10, 20, 40. Okay, so you have 2 points. And it says write the equation of line PQ. Okay, we could put a line on top. Okay, so line PQ. So what you're going to do is you're going to write out the formula. So let me show you. I'm going to write out the formula right here. Okay, but before I write out the formula, we're going to actually do the problem, because you will have to write the formula out in your homework. But right now we don't really have a formula, so I'm trying to develop the formula for you. Okay, so the idea would be to get any new point on the line. Now the new points on the line are called vector R, and I'll tell you what vector R is in a minute. But any new point on the line, which is vector R, which is really a point. Okay, but R is also a position vector, the position vector of any point on the line. So what it is you would take your 1, 2, 3, and you would add a certain number of M's. Okay, so we'd add a certain number of M's. Now, what was our M? Our M was 9, 18, 37. And then how many M's? Well, you get to pick. So they call it, in here, we call it T. So you put a T in the front. Now, T is not a vector. T is a parameter. Okay, and basically T is any number. So the 2, the 1/2. If I want to get actually hit onto point S directly, I would make T1. But that will give you all the points on the line, but written as a vector. So then if later you wanted it written as an actual point, then you would write it as a point. So it's kind of interesting. So this would be, this is actually called vector form. So let's write that. This is called vector form. And then you have to think of the shape. So you will kind of want to put 3D line, because today we're going to do lines and planes, and you want to be able to distinguish the difference. So this is vector form of a 3D line. There's three forms of lines, and there's 2 forms of planes. Okay. So now R, so this would be the answer, but let's write the formula out. So the formula is R equals A plus vector M, well, T times vector M. And T is not a vector, but make it rounded so it doesn't look like a plus sign. If you round your T like you round your I, then they don't look like plus signs. Okay, so this is the formula. And that's the formula where A is the position vector. So that would be, in our case, OP. And then M is the vector PQ. Okay, so that's how we found that PQ was 9, 18, 37. And then that's the equation of the line. That's it. That's one form, though. That's vector form. I'm going to show you the other 2 forms. Any questions so far? Just if you had to repeat, I know the theory is, is not what you're doing on your homework, but if you look at example 1, you have P, you have Q, you write the formula, R equals A plus TM. T, you don't know what it is. You could pick different numbers if you wanted different points on the line, but you just leave it. And then the 9, 18, 37 is the M vector. Okay, now it's not really called the M vector when you learn it. It's called the V vector. So what you usually see, and what you'll see if you see it from the other teachers, and if you ever see my notes from, say, last year, is this is the formula that they write. And then IB writes the formula as R equals A plus lambda B. But I like M, so I'm going to use M. Every year I'm thinking, I wish I had used M, because I keep calling V or B the slope vector. And then lambda is just another thing for T that they use in IB. So this is in IB. And then this, I would say, we'll call this USA. Okay, so those tend to be the equations that you'll see. So for right now, we're going to just call M what it is, which is the slope vector, especially because you're not in a class where you're hearing it every single day. Okay, and if your teacher uses A plus TV, perfect. Like you're asking them questions in class. I'm not sure if Mrs. Lindemann ever did this 3D vectors with equations of lines. So I'm not sure. So, but Miss Nicholas and Mrs. Tefenction are really good at it. I'm just not sure. Miss Lindemann might not have done it this way. Okay, but Miss Tefenction and Mrs. Nicholas will use what I've always used, which is V. I think they'll use the USA version. Okay. Okay, so any questions? I don't see anybody typing any questions or asking any questions, so I think we're okay. Okay, so that's the equation of a line. Now let me show you. It's going to be, this is called, we have 2 different forms of the line. One is called a parametric equation of a 3D line. Okay, and then we're going to also have another thing called symmetric. Symmetric is also called Cartesian equation of a 3D line. Okay. And you don't need this for AB calculus. What you need this for is you need this for our HL math class at our school if you decide to take it. If you're an IB student, then you can choose to take HL math. Or if you're an AP student and you also want to take HL, if you take our HL class, we also prepare you for BC. So my students in my HL class also take the BC exam, and then they also take the HL exam if they want to. Or they can be in the class and not take the HL exam, but learn the extra material. So if you're like, math's kind of like, I love math, and it's, if you're thinking that we at Walnut go kind of slow, then, which we don't, you guys are just awesome, but sometimes you'll be like, okay, like already I'm like learning it faster than it seems like, then HL would be a good class for you, or if you just love it. Okay. So you want to have gotten a B+ or higher in our class. this math analysis honors class because a lot of it is from math analysis honors, including this. Okay, so parametric equations of a 3D line and then symmetric Cartesian equations. So what you do is you convert from vector form. So let me show you what R is. Over here on the side, let's write what R is. R is actually the point X, Y, Z, but I'm calling it a point, but it looks like a vector. That's because R technically is a vector, but X, Y, Z, say X, Y, Z was some point, 100, 200, 300. If I write it as a vector, I can undo it and make it a point later. Just, the points in the vectors are the same if I'm saying, well, just start from the origin. If you ever want to make a point into a vector, you could start at the origin. Okay, but it's like a fake. To me, it's a fake vector because it's not really a vector. That's why they call it a position vector. It's where you are sitting and not really where you're moving. Okay, so R is X, Y, Z. Okay, and this step is a step I always show, but the next step I don't usually show, but I want you guys to guess. I want you to guess, if you didn't know, which you've never seen these before, what would you potentially do as a step? So somebody said, hey, 20 extra credit points. If you could think of any step to do next. Any ideas? You can either take off your microphone and say it, or you can actually type it. And no, it's not actually extra credit. It just feels better when you're guessing. Subtract. Oh, that's a good idea. Actually, they do that in some American books. Okay, so I like that idea. It would work. We're not going to do that, but I like that. Okay, so pretend extra credit for you, Patrick. Give you 5 pretend extra credit points. Okay, anyone else? Anyone else want some pretend extra credit points? Usually I think 50, just because 50 makes you feel like, well, I'm going to try something. Make it equal to T. Ooh, make it equal to T. That's actually going to be in symmetric Cartesian form. So 5 fake extra credit points for you, Sabrina. Anyone else? All of what you guys said is legal. It's just not the way that it's going to aim for parametric equation. Okay, come on, you guys. We need another idea. Max, what do you think? Annabelle, is she still here? Annabelle, are you still here? What do you think, Annabelle? What's something maybe I could do? Oh, you know the formula, so it's cheating. Okay. Okay. Anyone that doesn't know the formula? Now, Max, now you know the formula, Max, but nobody else is answering. So the question isn't what the answer is. The question is, what step could I do next? So, Max, could you answer what step I could do in one step only, not get directly to parametric equation of a 3D line? Can I add the 1 and the 9? Can I add the 1 and the 18? Or what would I have to do first before I add the 1 and the 9? Or add the 2 and the 18?
You have to distribute T.
I have to distribute T. Awesome. Okay, so you're going to distribute T. So that's 50 fake extra credit points. Okay, so plus, so we're going to distribute this. Now later we're going to distribute this in our head. Okay, so this one's going to have a bubble. Because I usually go directly from, and I'll show you, I go directly from one step to here. So this one is still here, XYZ. Okay. Next step, 20 fake extra credit points. Anyone? I'll write a hint, a structure hint. What do you think? Yes. Yes. You add the vectors. So to add the vectors, it's 1 plus 9t. And then it's 2 plus 18t. And then it's what? 3 plus 37t. Now, usually skip both of these steps, okay? So let me put bubbles on both of these steps because I usually skip both of these. And those of you who don't have me as a teacher, you don't know me very well, but I don't skip steps. So I don't like to skip steps at all. So if I skip a step, it's because I can really understand it and people can understand it directly. Okay, so if you think of this, so let me draw a little red wiggly line. So from here to the answer, okay? So the answer looks like this. So x equals, y equals, z equals. So it looks like those parametric equations from the augmented matrices. Okay, so we're going to just look at what the highlighted is. Okay, so we're not going to look at the two steps we just did. We're just going to look at this. Do you see now that I could say x equals 1 plus 9t? Do you see how I can do it just from the yellow highlight? I can say x equals 1 plus 9t. But we want to know that it's legal to do. So that's why I showed you in our first example, the bubble. So I do not usually show the steps in the bubble, but I wanted to show you that they're legal and not just go straight to the formula. Okay, so y is what? 2 plus 18t, and z is 3 plus 37t. And then this right here, this whole set of equations is called the parametric. And you want to kind of write it a few times on your homework because you don't have too many. So this is parametric equations of a 3D line. Okay, now, so what we have so far is we have the blue highlight is called the vector equation. Now, our textbook does not do that vector equation, vector form of a line. Okay, so it doesn't do that. And then parametric equation of the line, it does do, but it gives you just a straight formula. And that's what Max was talking about, that he had a formula. Okay, but the way IB does it and the way that I really do feel that it's easier to understand is if you start with vector equation of a line. When I learned vectors in college, it did not make too much sense when I was doing 3D vectors, but when I started to teach IB and I went to an IB conference, it all made sense. But I think it all made sense because they have a couple of structures that are different, including this vector form of a line. Okay, so that's called parametric. Now, one thing when you're looking at the parametric equation of a line is how could you look at these two equations and how can you identify the slope vector? Okay, so I wonder, I'm going to try to highlight two colors, so hopefully it turns green. So let's see. If you look at the vector form of the 3D line, where is the slope? The slope is next to the t. And then this is the initial point, but written as a vector. So in parametric form, where are those things? So the point shows up as the number by itself, and then the t, I'll just highlight it, the numbers in front of the t is where you get the slope vector. Because imagine you want a vector that's parallel to another vector. Do you care about the slope vector or do you care about the initial point? Oh, we could call it the initial point vector. Oh, that sounds kind of exciting, but it's really called a position vector. But initial point vector, that's A. So 1, 2, 3. Oh, wow. Okay. Okay, so symmetric Cartesian form. Symmetric Cartesian form of a 3D line is going to be what, let's see, Sabrina said. So Sabrina said, make it equal to t, but you do it from this format, okay? So draw an arrow from this format and solve for t, okay? And it looks like there's 3 answers. Okay. Okay, so t equals, how do you solve for t? Anyone have an idea what t is in terms of x? What's t in terms of x? Like t equals something with x's in it. Anyone turn off your microphone and tell me? Or type? Hey, Richard. Yes, I agree, Esther. So Esther typed x minus 1 over 9. And we do want to put it in that format. So we don't want to put like -1 plus x. We want to put it in like sphere format, x minus 1. Okay. And then this one would be y minus. So y minus 2 over 18. And then z is z minus 3 over 37. Now, Cartesian means you can only have x, y's, and z's. So I can't have the t in there. Now the t helps me, and when I want to go backwards, the t helps me. So I'm going to lightly cross it out. So it's not in my answer, even though it's in my brain. And then this is the last type. And this one is called, okay, so this one is called, and let's write it again. This one's called symmetric Cartesian. Those are two words that people use, symmetric or Cartesian. And that's equation of A, and this is a line. You want to keep writing 3D line. There are not enough practice questions for you to get to be an expert on this. So if you keep putting it's the equation of a 3D line, you wouldn't think that was the equation of a plane. Okay, so equations of planes are different. So let's see where we can find the slope vector. Anyone see where the slope vector lives in symmetric Cartesian form? So later on, if it says like find something that's parallel, if something's parallel. So where should I highlight? Where's the slope vector live in symmetric Cartesian form? Yes, the denominators. So the denominators, this will be the slope vector. So if you want to say, hey, I want something parallel to a symmetric, an equation of a 3D line, and I want a new line, and it's supposed to be parallel, then I would suck out the slope vector, and then that's what I would write. And then notice where the initial point is. Okay, so where's the initial point? What am I calling it? Initial point vector. Just for some terminology that might help you learn. So where's the initial point vector? Yes, it's the zeros. Hey, Patrick, that's a good way to call it. Yeah, I like that, calling it the zeros. I've never called it that before, but I like that. So it's like the, I always think of it as opposite, right? So I kind of think opposite, 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 you know, like when you want to move something to the right and up and down and parabolas and spheres, like imagine this was a sphere. I know there'd be pluses in the middle and equals r squared, but if this was the equation of a sphere, you would do opposite, opposite, opposite. So if you need the, if it's written in that format, x minus 1, then 1 is the answer. Yeah, but zeros is a very good description. Actually, that's an accurate description, and that would be the right math terminology. Okay, so the line problems, you guys, I don't call things easy, but the line problems, just like they're pretty straightforward. So I think that you're going to like them. So I'll do a couple of line equations. So let's say you are, it's a line, and it's parallel to this line. So I'm going to make kind of a harder one. So it's parallel to this line, 2 minus t, y equals 3 plus 2t, z equals 5 plus 10t. Okay, so I want it parallel to this and through 4, 9, 12. Oh, let's do negative. 4, 9, negative 12. Okay, so I want it to be parallel to that. And then even though the book says only parametric form, you want to practice all three forms on each question. Okay, so our book is an American book, so it does not have the IB version, but the IB version is really easier to understand than the textbook version. Like I said, the way I learned it was the United States way, and I didn't get it, and I was really good at math, so it's much better. It all makes more sense, the IB version, or the England version. Okay, so R equals A, which is your point vector, your initial point vector. And then this is plus M, our new, except hold on. Our new thing would be T times M. Oh, like an A plus TM is like an ATM you get to get money? Okay, but then you have to have the plus in the middle. In summer school 1 year, we used to call MV. So it would be like R equals A plus TV. And then I would always call it the ATV formula. And then my students would forget the plus on the test. So and then I was thinking, why did they miss that? And one of my students said one time, well, maybe because you don't say the plus, you say ATV. Okay, that's probably why. So A plus TM, but ATM, but there's a plus in the middle. Okay, so that's the formula. And then you have to look at the problem and say, okay, well, what do I have? Well, A, I'm gonna write that over here. So A is O, we'll call this P. So this is OP. And what is OP? It goes from the origin to that point. So then it's just 4, 9, negative 12. So you'll hear me saying, oh, that's, I'll call it a position vector, which is its official IB name or name from England, but, and probably in college as well. And then, because it's been many years since I went to college. And then, or I just call it point written as a vector. Okay. So that's it for that one. And then M. Anyone have an idea about M? So give me an M idea. What's an M idea? Parallel. Yes. Cool. Very good, Sabrina. Okay. So numbers in front of T. So let's just highlight those. I don't know if you have a highlighter. It might be nice to bring a highlighter. Okay. For some things like this. So it's the numbers in front of T. Now that's the slope vector, right? Isn't that the slope vector of this one? -1, 2, 10. Now, would this, we'll call it M parallel over here in the formula. Would your M parallel be the same? Right? So the slope vector of that one is going to be the slope vector of the new one. Perpendicular is more complicated. Has to do with cross product. Okay. So this one would be R equals A. So A is 4, 9, negative 12 plus T times vector M, which is -1, 2, 10. Okay, and then vector R is X, Y, Z. Oh, and we're already done with 1. This equation here, make sure there is a plus here, but this equation is called vector form of a 3D line. And then this one, well, I do write this step. Okay, so write that step so that you know R is the same as X, Y, Z. But then from here, you can go directly to parametric form. So it's a lot of writing, but it's not going to be super difficult for you. Let me go to the chat. Let me make sure I'm in the chat here. Okay, so X equals what? 4 plus -1 times T. Okay, so X is 4 minus 1T. And then I'll highlight this one in yellow just so you can see on the screen. I don't think that's necessary in class. Then this one is 9, right? 9 plus 2T. So 9 plus 2T. And then Y is -12 plus 10T. We'll wiggly line it. And then this one, and then you do the little swirly things, and then this is the answer. And then what is this? It's a 3D line, but the form is called parametric form, which looks like the parametric form that you learned earlier in the year. Okay, so this is called vector form. Okay, so this is called vector form right here. And then this one right here, well, it's right here is called parametric form, the 3D line. That looks kind of like I'm crossing it out though. So that's parametric form of the 3D line. And then you can get to symmetric form, right? So symmetric form, solve for T. Okay, so solve for T. So T is X minus 4 over -1 equals Y minus 9 over 2 and Z plus 12 over 10. And this is symmetric Cartesian form. And then cross out the T lightly so that it doesn't look like it's part of your answer. Notice the slope on the bottom is the slope, and the point on the top is the initial point, and then that's negative 12 because you have to do opposite if you were trying to go backwards. Okay, so there's 3 answers to the line problem. But if you read the instructions, I'm reading the instructions right now, it says point parallel to, and it says find a set of parametric equations, and B, if possible, a set of symmetric equations. Now, the symmetric equations are possible no matter what. It is okay to have 0 in the denominator. So if there was no t, you would have a 0 in the denominator, which is really weird. But somebody explained it to me once. Like, what if I was doing a ratio of boys? Let's do it different. So let's say I was doing the ratio of puppies to boys in my house right now. The ratio of puppies to boys, 0. Now, we never do ratios with 0, right? So it looks funny to us, but it makes sense and it's legal. So it is okay to have zeros in the denominator of these fractions, which feels wrong, but it actually, IB has had questions like that, and the 0 shows up in the denominator in the answer. So it's kind of disturbing in our, there's no zeros allowed in the denominator philosophy, but it does make sense in ratios, and it does also make sense in this one. Okay, so and then the lines, just make sure you do all 3 formats. Okay, and then the other questions give you 2 points, and then they have you find a line. So that was our first one, example 1. You have 2 points, and you're finding the line. You have to find the slope vector first, and then you substitute it in, and then you simplify. So the lines are pretty nice. They're pretty straightforward. You're going to like them. Okay, you're going to like them. No cross product needed. That's it. Sketch a graph of the line. I hope you don't have to do that one. Okay, perpendicular to general equation of the plane. Okay, so now we're going to do planes. I wonder if I should do 2 videos. You guys are going to still be on Google Classroom, but let me stop this video, and then it'll be faster, and then I'll do the line part. So if somebody wants to learn lines differently. So